Welcome to the deep dive. Today we're digging into something, well, pretty vital. Stopping fraud, in real time. As money just zips around digitally, our mission, to look inside IBM Safer Payments, it's a leading solution, and see how it tackles this massive challenge. We're drawing insights from their own materials, IBM Safer Payments, real-time fraud prevention to see how they stay ahead. So the big question really is, how do you catch these fraudsters when everything's moving so incredibly fast, lightning speed, right? And that's where it gets really interesting.
It really is like a digital arms race.
Yeah.
Billions flying around every single day. And the fraudsters, they're always coming up with something new. It's relentless.
Yeah.
And it's not just about the money. It's about trust. Trust in the whole system. So staying ahead means being faster, yes, but also, well, smarter. Much smarter.
Right. So if it's an arms race, you need some serious tech. And IBM Safer Payments, that's the tool, a big AI-powered platform.
Exactly. That's the core idea. It's designed to give banks, financial institutions, the power to react fast. And not just react, but control things precisely with really high performance. It's about giving them the edge.
Okay, so AI-powered. What kind of AI are we talking about here? What's under the hood analyzing all that transaction data?
Well, it uses some really cutting-edge stuff, things like neural networks. So they're great for finding those hidden, tricky patterns. And random forests, decision trees, algorithms designed to sift through enormous amounts of data very effectively.
Okay, and you mentioned something, explainable logic before. That sounds like this white box AI idea, right? Not a black box.
Yeah.
What's the big deal about that? Why does it matter if you can see how the AI decided something?
Oh, it's absolutely critical. Huge difference. A black box gives you an answer, fraud. Not fraud, but know why.
Yeah.
Safer Payments, with its white box approach, actually generates rules that people can read and understand. So imagine you're a fraud analyst. You can see the logic, you could check it, you could even tweak it. That builds trust. Plus, for compliance, for explaining things, it's essential in finance. You need to be able to explain decisions.
Right. You can't just say, the computer said no, and it even helps discover new rules. The AI suggests them.
Yeah, that's the AI-augmented rule generation part. Machine learning spots potential new countermeasures, new rules, and then the human experts, they review them, test them, and integrate them. It's a partnership, really.
So think about this. For you listening, why does that matter? Well, if a black box blocks your card, good luck figuring out why.
Exactly. And from the bank's perspective, how do you audit it? How do you refine it if you don't understand it? That transparency, that explainability, it's just fundamental.
Okay, so explainable AI is key. But you also mentioned speed, agility, staying ahead. How fast can they actually roll out new defenses? That brings us to this model factory idea.
Yeah, think of it like a rapid response lab for fighting fraud. The really standout thing here is the speed. Teams can build, test, and get new machine learning models and rules live in, well, days or maybe weeks, not months like it used to be.
Days or weeks instead of months. Wow.
It's a huge difference. Fraudsters move fast, so you have to iterate quickly. This lets institutions react almost immediately to new threats before the losses pile up.
And they don't make you throw out your old work either, right? This bring your own model thing, BYOM.
Right, BYM. It's an open platform. So if a bank already has its own fraud models, maybe built with different tools, open source stuff, they can integrate them. It offers a lot of flexibility, lets them leverage what they've already built, their own data science work.
That sounds really practical. Avoids vendor lock-in too, I guess.
Absolutely.
Yeah.
Plus, nearly everything is configurable through a web interface. Data feeds, models. You can adapt it very quickly. Hooking up a new data source might take just minutes. It's built for that kind of quick adaptation.
So let's connect this back for the listener. How does this whole model factory approach, really practically, help your bank protect your money better?
It changes the game from being reactive and slow to being proactive and, well, nimble. A new fraud scheme pops up. They can analyze it, build a countermeasure, test it out safely, and push it live super fast. Sometimes, like within a week. That means less opportunity for fraudsters, faster protection for you. It directly cuts down the time they have to exploit things.
Okay, speed and agility, check. But fraud isn't just on credit cards anymore, right? It's everywhere. Online banking, mobile payments. How does Safer Payments handle that? Does it cover everything?
It does. It's designed for all-channel, cross-channel protection. So yeah, credit, debit, online, real-time payments, mobile, the whole lot. But the really clever part isn't just covering them, it's connecting them.
Connecting them. You mean looking at activity across different channels together?
Exactly. Holistic profiling. It watches behavior and how payments flow across all the channels someone uses. This gives a much richer, more complete picture of what's normal for a customer and what's, well, suspicious.
And why is that so important? What's the payoff?
Two big things. One, it helps massively reduce false positives. When your own legitimate transaction gets blocked. Super annoying.
Ugh, yeah, hate that.
This holistic view helps avoid that.
Mhm.
And two, it's much, much better at catching sophisticated fraud, the kind that deliberately tries to hop between channels to hide.
Right, because if you only look at one channel, you might miss the bigger picture. A fraudster testing a card here, then making a big purchase somewhere else.
Precisely. If you're only looking at, say, card transactions, you're blind to what's happening in online banking or mobile.
Yeah.
Fraudsters know that. They exploit those silos. A cross-channel view just eliminates those blind spots. It lets you see the whole pattern.
Okay, so covering all channels, connecting the dots, that sounds like it needs some serious horsepower. And it has to be reliable, right? Can't have the system going down.
Absolutely. Performance and reliability are paramount. We're talking enterprise scale here. It can handle thousands of transactions every single second.
Thousands per second.
Yep. And the decisions, fraud or not fraud, they happen in milliseconds, like tiny fractions of a second. Some clients report decision times as low as 3.5 milliseconds.
Wow. So it catches the fraud before the money actually goes.
That's the goal. Stop it before it leaves the building, so to speak.
At the uptime, the reliability.
Designed for 247, they aim for 99.999% availability, 5 nines.
5 nines. That's, what, minutes of downtime per year?
Barely any. It has to be constantly vigilant because fraud doesn't take holidays.
So for you listening, when your payment goes through instantly and securely, what does that speed and rock-solid reliability mean for the bank protecting you? What's the real impact?
Well, beyond just making things smooth for you, it lets the bank be much more confident in its fraud detection. They can use tougher rules, be more aggressive in spotting potential fraud without constantly worrying about slowing down legitimate payments or the system crashing. It means they can shift from chasing fraud after it happens to actually preventing it in real time. That saves them money, sure, but it also builds your trust because things just work smoothly and securely.
Okay, that speed milliseconds is mind-blowing. What makes that possible? I think the source mentioned something about a special database, an in-memory NoSQL thing.
That's right. The architecture uses a purpose-built dual-access in-memory NoSQL database. That's quite a mouthful, but it's key.
Break that down for us. In-memory, NoSQL, dual access.
Okay, so in-memory means the critical data it needs to make decisions is kept right there in the computer's main memory, the RAM. Super fast access, not like pulling it off a slower disk drive.
Like having the info right at your fingertips instead of running to a filing cabinet.
Exactly. NoSQL just means it's not a traditional row and column database.
Yeah.
It's designed differently, optimized for handling huge volumes of varied data very quickly, good for transaction data, and dual access. That means it's built to both read and write data extremely fast at the same time. Crucial when you're constantly processing new transactions while analyzing historical ones.
Got it. And how does this specialized setup, maybe with compression too, help catch fraud in those milliseconds?
Well, the in-memory part avoids the delay of disk access. That's a huge time saver. The NoSQL structure lets it query and analyze all the different pieces of transaction data almost instantly. And yeah, the compression is smart. It understands payment data structures, so it can shrink the data down really effectively. Less data means faster processing, less memory needed. It all adds up to that sub-second decision speed.
So it's fast, it's smart, but how do the banks know it's actually working well? And how do they improve it? Are there tools for that?
Oh yeah, absolutely. It comes with a whole suite of analytics and simulation tools. There are tools for constantly monitoring performance. How well are the rules working? Are we catching the right things? Or false positives creeping up?
Like a dashboard for the fraud fighting operation.
Pretty much. It gives them real-time visibility because, like we said, the threats change constantly. You need that feedback loop to stay effective.
And improving it, making rules better.
That's where the simulation comes in. They have a sandbox environment. So before you roll out a new rule or a new model into the live system, you can test it thoroughly in this sandbox using real historical data, see how it behaves, what impact it would have.
Ah, like a flight simulator for fraud rules. That sounds crucial. Why is that sandbox so important? What could go wrong if you just pushed a new rule live without testing?
Oh, lots could go wrong. It's a really delicate balance. Fraud detection. You might write a rule that looks great on paper, catches a new type of fraud, but maybe it accidentally blocks thousands of perfectly legitimate transactions. Huge headache.
Yeah, the blocking too many bagels scenario.
Yeah, exactly. I mean, it might seem minor, but scale that up. You get angry customers, huge operational costs, dealing with complaints, maybe even lost business. The sandbox lets you see that potential impact before it happens. You can fine-tune the rules, optimize them, make sure they catch the bad guys without annoying the good guys. It prevents costly mistakes.
Okay, one last feature mentioned was multi-tenancy. Hierarchical multi-tenancy. Sounds complex. What's that about?
It's actually really useful for bigger organizations. Think large banking groups or companies that process payments for lots of other businesses. Multi-tenancy means you can run multiple separate instances of Safer Payments on the same underlying system. Each tenant can be customized.
So, like, different departments or different client banks could have their own tailored setup, but it's all managed centrally.
Precisely. And hierarchical means you can structure it, maybe a main setup for the parent company with specific variations for different regions or business lines underneath.
Okay, so who really gets the most value out of that? And why is it important given how big and complicated banks can be today?
Definitely the big players. Global banks, payment processors handling payments for hundreds of smaller banks or merchants. Imagine a bank operating in, say, 20 different countries. Fraud patterns are different everywhere. Regulations are different. Multi-tenancy lets them have a specific, tailored fraud strategy for Germany, another for Brazil, another for Japan, all running efficiently on one platform. It gives them that needed customization at scale without having to build and manage completely separate systems everywhere. It's key for managing that kind of complexity efficiently. So when you pull it all together, IBM Safer Payments really is this very powerful, very agile, and importantly, transparent platform. It gives institutions the tools they need for real-time fraud prevention, letting them adapt quickly and really cut down on those fraud losses. It shifts the balance in that arms race.
Right. And for you, listening at home, what's the bottom line? Well, it means the people protecting your money can do it faster, smarter, and adapt to new tricks as they pop up, hopefully making your financial life a bit smoother and safer. And maybe a final thought to chew on. We talked a lot about explainable AI here, the white box approach in fraud detection. If we can make AI understandable and trustworthy in a field this critical, where else could this apply? What other complex systems could benefit? Maybe fundamentally changing how we trust automation. Something to think about. Thanks for joining us for this deep dive into the fast-moving world of real-time fraud prevention.